Day 29, page 712, problem 67. So we started this problem in class, but let me just refresh your memory. They're telling us that I3, the current in the middle, that middle branch there, is 1 amp, but that could have been deduced because, kind of like we were doing in the last problem, the 5 ohm and the 10 ohm resistor, well, if we look over there, the 5 ohm resistor and the 10 ohm resistor on the left really can be combined into 15 ohms. In fact, let me just kind of do that. The 10 ohm and the 5 ohm basically make 15 ohms. They're in a series, so to simplify this circuit, semi-simplified, they're acting like a 15 ohm resistor. And there's 2 amps going through that branch, total potential difference of 30 volts. If we would have left them separated, the 5 ohm resistor would have had 10 volts, because 2 times 5 is 10 volts, and the 10 ohm resistor has 20 volts. But totally, that's 30 volts. And that branch connects this junction up there, if I call it point A, and point B down here. So between point A and point B must be a 30 volt potential difference, which basically is in parallel with the battery. So the battery must be 30 volts. You can, you don't even really need the junction rule for that, or the loop rule for that. That must be 30 volts. And the middle branch must be 30 volts, and the outer 2 resistors on the right-hand side must be a total of 30 volts as well, potential difference, because everything's in parallel here. So that applies to that middle branch, which we know if we have 30 volts in that middle branch and we use Ohm's law, V equals IR, that would give us I3 being 1 amp, even though they already told us it was 1 amp. It had to be 1 amp. Now, going back over to the far left here, we're looking at I1 over here. I'm using blue for currents. Well, if basically we know everything, we got the current on the right-hand branch, way over here on the right-hand side, in that branch is 5 amps. That's given, 5 amps. Middle branch was 1 amp, and the left-hand branch is 2 amps. That was given as well, 2 amps. So those are all currents coming out of this junction point A up here. And then the 1 amp coming down the center. So we have 5 plus 2 plus 1, that's 8 amps. So I1, I sub 1, the current supplied by the battery must be 8 amps, because that's then being split 3 ways, most of it going with the smallest resistance, which is the far right. We're going to find out how much total resistance we have on the far right here in a second. But we know that, going back to the far right, that 2 ohm resistor has 5 amps of current, so that's 10 volt potential difference. So this is 10 volt potential difference. So the resistor down here on the lower right must be 20 volt potential difference, because we have to have a total of 30 volts there in that branch, which is in parallel with all the other branches. So now we can use Ohm's law here for that unknown R resistor, V equals IR, for the unknown final bottom right resistor. The potential difference is 20 volts. The current is 5 amps. So R, well, you can see it pretty easily here, is 4 ohms. I think that's the last thing we had to find here is R. We had R, V, and I. As you can see once again on the far right, we have a low resistance way over there. The 4 ohms we just found plus the 2 ohms is 6 ohms. That's why we're getting a lot of current over there, 5 amps in that branch versus the other 2 branches where there's higher resistances.